Edge computing-driven transformation of data, management, and applications. Edge computing is a buzz phrase on the ascendant, a vital part of the 5G project. But what exactly does it mean? Smartphones, wearable devices, smart toasters? All these are busy computing at the very edge of the cloudscape. Is this what it's all about? Edge computing is more fundamental than that. It's about the distinction between data being processed centrally to provide information and data being processed at the periphery to trigger action, as in automated systems and IoT. Let's hear it from Gerry Christensen, founder and CEO, Mind Commerce, as he introduces the discussion, and his three participants, Kevin Deierling, Senior VP of Marketing, Mellanox Technologies, Rick Calle, Head of Business Development, Microsoft AI Research, M12, and Sarva, Advisor, Head of Product Strategy, NetFoundry.
Edge computing, first of all, what is it? I had a conversation recently with another analyst, and I think we were probably about 15 minutes into the discussion before I realized that she was thinking edge compute as in a smartphone, or maybe a wearable, or maybe some kind of customer prem device. And I was thinking an extension of core cloud computing. So that's the latter is what I think of most of the time when I talk about it. And for purposes of this discussion, unless I state otherwise, or unless one of the panels state otherwise, that's what I'm talking about. But again, what is it? Or more to the point, where is it? And so I talked to a lot of leading edge compute companies as part of our research practice. And one of the things that I was really surprised in talking to them is it's kind of all over the place. From a deployment perspective, we feel that we will find some edge computing at the base station, so that would be a lot of edge computing. In some cases, there will be an extension of existing data centers, whereas instead of having one main data center, you might have regional data centers. And then there's a whole bunch of other issues that come up, such as who owns it, who manages it, who controls it. In some cases, it's hard to even discern unless you're one of the edge what it looks like. I was in New York City recently, and I saw some 5G remote radio heads and BBUs, and right next to it was a bunch of boxes. Pretty sure it was edge computing, but not positive, but it was certainly a good location for it. So what I'm gonna do is run through a few initial slides here, and then I'm gonna turn things over to the panel. We've got a great panel here. I'll let them introduce themselves. But let's go ahead just to tee this up. Not a lot about Mind Commerce and who we are. We'll be in the press pack if you want to find out more. But one of the assertions that I've made in some of our research and in groups like this is that edge computing is already there. It's actually already there for 4G LTE, in particular at a lot of private wireless implementations. So it's not like it's an entirely new thing, but what's really going to be new and important with 5G is arguably it's going to be a requirement. And by that, I don't mean a requirement for bandwidth, I mean a requirement to preserve the latency gains that we're going to have with 5G. And so we all know that with 5G right now we're rolling out the non-standalone. So we're going to need to have standalone, we're going to need to have the core in order to have the proper amount of latency. But I would argue we're also going to have edge. And so what does edge do for us? It enables us to not have to go all the way through the core for all the packets. It enables us to go directly to the internet in some cases, or in other cases, if there's caching, to do the processing right there where the application engagement is actually happening. So what is it needed for? There's three classes of 5G services. There's the so-called enhanced mobile broadband, which is arguably an extension of what we're already doing with 4G. So a good example for 5G may be cloud-based gaming, for example. There is what they call the URLLC, the ultra reliable low latency communications apps. So that would be things like critical communications and virtual reality. I don't think of that as critical communications like public safety critical, but certainly critical in the sense that you need to have really low latency or it's not going to be a meaningful, useful experience. And then another category is the so-called massive MTC, the massive machine type communications. Massive in the sense that when 5G rolls out for IoT support, it's going to be highly scalable. And so what I'd like to talk about as part of this discussion is what does that mean for each one? I'm going to ask the panel to share some use case scenarios with us. And here those are. And one of the things that we find when we look at these different classifications of services is they have some of the same needs for edge computing, but in some cases they have overlapping needs that are exclusive to the other ones. Some of them require a high degree of reliability and others do not. And so that can be a problem. It can be a real challenge. This is a diagram that I've used in the past to speak to some of the issues around edge computing with respect to things like security and things like data usage. In other words, what data needs to be sent back to the core computing versus what data could be processed in real time. So one of the advantages of edge computing is you can actually process things closer to where things are happening, and you may be able to make some real-time business decisions. One of the things that I believe edge is going to set up is data as a service opportunities. So whereas right now, data as a service is available for static data, data lake type implementations, with edge computing, all of a sudden there'll be a new thing available, which will be real-time data. So with that, what I'd like to do is tee things up for our panel. We've got a very distinguished panel here, and I think what I'd like to do is let them introduce themselves, and I'll start with Rick at Microsoft.
I'm with Microsoft M12, which is Microsoft's corporate venture division, or ARM. As well, I work with Microsoft Research in business development for new technologies coming out of Microsoft Research. So I kind of have an interesting view outside and inside. Prior to this, Gerry, I was at Qualcomm. So, when you talk about 5G, when you talk about edge computing, Qualcomm was all about that from the silicon side. So we can maybe have a few discussions on that. Then I don't know if some of the folks from SpyCloud are here. They're one of our portfolio companies. I was just trying to think of whom have we invested in who's here. SpyCloud, Sentient is an edge computing AI chip company that we've invested in. There's some security companies, cybersecurity and what have you. So pretty much across the gamut for edge and data center.
Hi, I'm Kevin. I moved, so you wouldn't notice that I was still on the panel. But actually, it's interesting. We talked, the first panel I was on, we talked about smart, secure cloud. And then I was more talking about our Ethernet switches here, or really for IoT, we're talking about what we call an I/O processing unit, an IPU. Maybe I should call it an IoT processing unit. So it really reflects the reason I'm here on this panel is it reflects the breadth of our product lines. But here it's really what we call an IPU, or a I/O processing unit.
I am Sarva. I head products for NetFoundry. Edge computing is definitely an emerging space for us, whether it's cloud service provider or data center-based networking or edge computing. Some of the requirements around zero trust networking and security in some of the panels that we have heard earlier stay true, irrespective of where the workload resides, and we'll talk more about it during the panel today.
Great, thank you. And thank you, Sri, for filling in at the last minute as well. I'd actually like to start with you. One of the things that comes up, at least for me, all the time with edge computing is almost a rhetorical question: why do we need it? And so that encourages another question, which is, what are some of the use cases for it? So from your perspective, share some of the use cases that you've seen, heard, or that you anticipate in the future.
Sure. So I'll answer the first question: what does edge mean? And as Kevin mentioned, there are different connotations, different descriptions of the edge. Overall, if you think about edge, it's no different than what cloud computing. It's a different manifestation of a cloud computing paradigm, where instead of hosting the workload in a specific cloud service provider's infrastructure, you're hosting it closer to wherever the users or the devices are, mainly because of the nature of the applications which require real-time data processing or low latency type requirements, which require the workload to be placed closer to the user, whether it's confined within a data center or whether it's confined closer to a cell tower in the form of a micro data center, or if it's hosted in a cloud service provider's data center. You want this edge compute to pretty much manage and orchestrate the workloads as if you were hosting it in any of the cloud providers as environments, for example. So the requirements that hold good for cloud automation would still hold good for an edge computing environment, whether it is manageability and booting of the device or manageability of the infrastructure, network and security, constraints around the edge compute, and the architecture. How does this edge compute tie into your backend data center or to the cloud of your preferred cloud of your choice? It's important that the applications that are being targeted for the edge, and we'll talk about it in a moment, require an architecture that will let these apps speak to the backend data centers or cloud service providers in an air-gapped manner. Right? And coming to the use cases, I would like to categorize it in 3 different ways. Wherever there's a requirement for business automation or the way people interact with things, could be smart metering or industrial automation, factory automation type use cases, or real-time processing of the way people communicate, more immersive collaboration or communication mechanisms that are evolving in the AR/VR space. So those are some of the primary drivers. Clearly, IoT is one area that's driving edge adoption. And as it starts to emerge, we will see more and more enterprises adopting to it.
Okay, great. Kevin, how about you take that as well? And I'd love to hear a specific use case, maybe for a particular industry vertical.
Sure. So I actually like to use the analogy of the human visual system and think about the brain was sort of the inspiration for deep neural networks and AI processing, and then that's running on GPUs. If you think about visual systems, though, it turns out that in your eye, the retina is actually an edge computer. It's doing a tremendous amount of processing. It's not a digital camera that's sending individual pixels to your brain and all of the visual systems is done in the cortex of your brain. It actually doesn't work that way. If it did, there'd be too much data going through the optical nerve to your brain. So your eye is actually doing pre-processing. It detects motion. There's directional specific, up, down, left, right. Certain neurons only fire if they see those directions. It detects visual bilateral symmetry. What does that mean? Well, if things are reflected, maybe 2 eyes are looking at you, maybe something's about to eat you, it sends a signal to your brain that would be useful information. Maybe it's somebody of your own species that's looking at you. That's also useful information if they're interested in you. Very interesting. The eye is actually doing that remote processing. We see the exact same thing in IoT. And so if we look at an application, a specific application of now the self-driving cars and even just any car that's accumulating a massive amount of information. When that car pulls up, there's a tremendous amount of data, and you plug into a charger in a parking lot somewhere at the store. You can't send all of that data to the cloud. You have weeks worth of accumulated data inside of an automobile. And so what we see with our I/O processing units is they're doing effectively compression. They're extracting features that are relevant. So don't send all the raw data to the cloud. It's just inefficient. Instead, remotely extract features. What was the characteristics? What are the temperatures? What experiences did that car see over the course of weeks, potentially between charges? And then send that extracted feature information. So that's one example where we've seen it.
I love that analogy. And if we could kind of continue with that analogy, we could think of the eye and your optic nerve as an API. So your eye, I guess in that analogy, would be the edge computing, your brain would be the core cloud, and the optic nerve would be a proprietary API. Hopefully nobody ever hacks into that. So along those lines, it would be interesting to talk a little bit more about the ecosystem. So Rick, what do you think? Do you see any unique areas in the ecosystem where maybe some companies that you're involved in, like startups, are doing anything in particular that you think would add a lot of value as the ecosystem evolves?
Yeah, sure. So, I like that eye analogy. We do hack the eye, optical illusions, right? Those are effectively things that zap your retina and your visual cortex, right? So we can't do DDoS and those kinds of, well, maybe we could, right? If you kind of zap people with lasers, you deny them somehow. Use cases, I like that. So if I think about edge, I've done a lot of work in this, and your company did a pretty good report of this too, Mind Commerce. And it seems to me in the industry, if you think about enterprises that have tons of data, either in the field or in the corporation, big challenges are two. It's just two. Use case. What's the use case that they can deploy? And basically it comes down to why. Why would they even want to do edge? And then the second thing is, how do you actually deploy it out to some edge device, right? Those are the two gaps. And it takes an enterprise to really put some things together. So for instance, here I'm going to make up an example, but I'll give you a concrete one. Let's say a brick and mortar store, let's call it Target, Walmart, Sam's Club, Costco, you name it, wants to understand the activity in their store. Where are the hot spots, right? Where is glass breaking? Where are there people chattering? Where are kids running loose? Those are analytics. Those are things they need to know, but they need to worry about privacy. So you can't use cameras. You can't send that stuff to the cloud. People don't want to be observed. You could use sound as an example. So it takes someone in the company to say, how do I detect activity? How do I do it privately? And what can I use to measure it? That's the hard part. And so it's that ideation gap that I see as being a challenge. Next part is, how do you then put that down on a device that runs on a battery, right? What are the tools and mechanisms after you've done a proof of concept in the cloud? How do I get it on that chip or server that's in the back closet of Target? All of these things are edge computing. A use case. So here's a company that put it together. FarmBeats. I don't know if you know this startup. And there are others in Israel, kind of like this, where imagine you want to detect disease coming out of your crops as they're growing, and you want to detect it right away without sending people out in the field. Well, why not send drones out there? Just fly around autonomously. You can pretty much have them, just like your autonomous driving car, you can have autonomous drones today. Let's build that, and they did. And then do the processing on the edge, because the other part of IoT, of the use cases, is cost, right? Why do you want to do stuff on the edge? Privacy and cost. It takes too much money to upload petabytes of data for this car, or terabytes for this vision system that's on a drone, terabytes per second of data. So you want to crunch it on the edge, on battery power, and try to do the smarts locally. So anyway, those are two interesting use cases that we've run into.
Okay, that's great. So an open question for the panel, whoever wants to take it, or I'll pick somebody. Edge computing, is it going to be managed much in the same way as, and I'll use the AWS example, the core cloud, and or will there be some differences? And one of the things that I think about a lot is the need for APIs, the need for an open ecosystem where you have managed service providers and many different app providers involved. And I think we touched on orchestration earlier today and also yesterday. And so we could probably talk all day about just that. But what are your thoughts around that? Like, how do we have security, and we should probably talk about security here in a minute as well, security and privacy in that kind of a world where we're opening it up, and yet we have another place of attack, not just the core cloud, but the edge. So thoughts or comments on that? Whoever would like to take that?
I can take that. On the API and automation front, as Kyle was mentioning in the previous session, I think having a uniform abstraction or where your workload resides, whether it's on-prem data center or a core cloud provider or the edge compute, automation is the key. Having a way to manage these workloads through an API or an automated way of deploying, not just day zero provisioning, but ongoing maintenance is a key. Right from the day you deploy the infrastructure to onboarding your first or nth application, it becomes extremely important around the manageability and operability of the environment, especially on the edge compute side. I think the cloud compute, the lessons learned from the cloud compute paradigm can definitely be applied and leveraged for edge compute when it comes to API and manageability and automation. Coming to security, I just wanted to say that given the edge is a manifestation of cloud, the anticipation is that there would be a lot more distributed edge computes deployed across the geographies. Like I said, it could be a micro data center near a cell tower, or at a remote location where your administrators or operators do not have access to. Security becomes paramount. It's not something that the cloud provider or the data center have direct access to. Hence, having an air-gapped environment, both from a network and app level security, becomes extremely important, where even if the infrastructure gets compromised for whatever reason, there shouldn't be any lateral movement in the way they gain access to the apps or the data, which is a premium, which is the reason why the infrastructure is being hosted. So what I like to say is silicon to cloud security becomes paramount of importance. And I can lean on Kevin to talk about how they are sort of solving the trusted execution environment in order to drive the silicon root of trust for applications deployed at the edge.
Yeah, so thanks. That's a great softball pitch. So, the IPU that we talked about, the I/O processing unit, a critical piece of that is that you have a hardware root of trust built into the processor itself. So the devices at the edge have to maintain their own keys, have key management integral to them, and basically be able to authenticate everything, do secure firmware updates. All of that has to be built. The nice thing, and I think to your point about APIs, before I was at Mellanox, I was actually the chief architect of a company called Silver Spring Networks that built the smart meters. And there was a question earlier about the security in the smart meters. I actually did the chips that did the security in those meters, and it was before the standards were defined, before the APIs and this idea of a secure root of trust had been defined. Now, fortunately, on my team, I had a guy that was working on the security who was from Russia originally and then had lived in Israel. And I can tell you that there is no more paranoid person in the world that I've ever met than this one guy. And when we started talking about the supply chain for building those secure meters and how we were going to get these keys into them, he started asking, well, where are you going to build those? And well, we'll probably do it at a contract manufacturer. Where's the contract manufacturer? Well, maybe in Mexico, maybe in Taiwan, maybe in China. He said, and we'll program it in with the secure keys, the private keys. You don't think there'll be a wire coming out of the computer to sniff the keys? We actually ended up building something that really is what is today a secure root of trust, where the chip itself has a random number generator and defines its own keys. So I designed it. I can't even break the smart meters. That's going to become critical. APIs, in my opinion, on the IoT market is what's limiting the market, because these markets are all fragmented. If everybody goes off and invents their own, for this specific application, here's your API, companies like ourselves will not be able to drive our innovation. So we're looking to folks like Microsoft and others to define an API. We really need these APIs to become standardized so that we can sell to a broad range of IoT applications using standard APIs.
All right, so here's another one, unless you want to pick up on that, Rick. I'll let you start with this, Rick. Who owns the edge, who manages the edge, and who uses the edge?
Oh, man. Wow, that's a tough one. You would give me that one, wouldn't you?
Oh, sorry. Well,
So why don't I start with manage, right? Because ultimately that's the system integrator, whomever puts edge thing, right? Edge, as you've heard, it could be anywhere from actually just a data center in a box in the back closet. It could be your communications hub, right? You see that model where, your Wi-Fi, maybe even 5G, and, LTE backhaul is in a hub that's might be in the ceiling somewhere, or there's compute in that. Or it could even be these little battery-powered devices. So I think it's tough to say one answer to who manages that, right? But let's pick a segment, and let's say that middle segment where it's the hub, or kind of these devices like just say Raspberry Pi type. It's a quad-core ARM or some sort of computing device of that caliber. I don't know. Maybe IPU has more or less compute.
ARMs, lots of ARMs.
Lots of ARMs, right? And so that's sort of the de facto standard. Now, anyone who's going to do edge computing for enterprise or for commercial product will probably use that. Unless they need something that's battery powered, that's a whole different story. They'll use Qualcomm's or someone else. At that point, it starts with root of trust. At that point, above that, once you have a secure root and a secure way to boot up and attest, that tells you, did someone take over my device? Did someone try to hack in and put some new firmware so that now it's owned by some guy sitting in Vladivostok or in Greenland somewhere, or who knows where, right? Or is it still owned by the enterprise that deployed it? That's the key thing. Attestation, root of trust, and a way to revoke that stuff. Once you have that in the hardware, and now there are multiple vendors, and now I hear of Mellanox with this, then there's a software layer on top that manages all of that stuff, those keys and the certificates, and how do you actually ask for and actually do a firmware update securely. Microsoft is in that space. We have something called IoT Hub or Azure IoT. I think some of you are partners in that. I won't call it Windows on IoT, but you can think of it as the operating system that's above the hardware layer. That manages it, if you will, at some level. But then your app really is the thing, and your deployment really has to manage when do you update, where do I put the data, how secure is it? Do I do AI on the edge? That's really my thing, is how do I get AI models from the cloud and have them running on that edge device? And that's another challenge. How do I deploy and update models and then get data back that I can then retrain on privately? So who owns it? Usually it's whomever deployed that system integrator.
good answers, good answers.
Yeah, can I just jump in quick? I think if you say who owns the edge, it's a scary answer, but we do. It's the consumers that are deploying all these things. And I just was thinking about myself. I've got cameras in my house. I have a music server. I plug my drone into my network. And I know a lot about security, and I know all the things I should do, but I don't do. I don't secure my home network. And so it really comes back to that software APIs. We can't leave it up to people like me. Even I'm a techie, and I still don't do it. So it needs to be automated. It's incumbent on the vendors and the API vendors and the software vendors that we're building these products that there should be something that says, hey, here's the stamp of approval that you plug this in, and it is intrinsically secure. I know the meters are secure, and we went to great lengths to make that secure, but it needs to be everywhere. Everything we're going to plug in with IoT devices, we can't leave it up, certainly not to me, and definitely not my wife.
It's more of an ecosystem play. There's an infrastructure provider, software layer, a silicon provider, and an orchestration layer, and end of the day, the applications that define the edge. So it's more of an ecosystem play, at least that's what we are seeing today in the market. And I think more and more it'll converge to a certain set of providers managing and owning the platform.
Great answers. And with that, we're going to go ahead and wrap up because we're about out of time. And I think that those were really good answers because one of the things that I've seen with our research into this as well is that it's many things to many people. There's actually many hands touching it, and it's going to be probably an order of magnitude more complex than core computing because of that. especially when we start having applications that we can only just imagine right now. We can imagine some of them like virtual reality, but the hard thing to imagine is how they'll actually be used. So thank you very much to the panel. I really appreciate it, and thank you all for listening.
Thank you.
So who owns the edge? Well, apparently we all do. Unfortunately, that includes rather too many owners with potentially malicious intent. Maybe we should learn from Kevin Deierling's example and require paranoia as an essential mindset for all edge security workers. Thank you, Gerry Christensen from Mind Commerce, for hosting this highly stimulating discussion. And thanks to his panel members, Kevin Deierling, Senior VP of Marketing, Mellanox Technologies, Rick Calle, Head of Business Development, Microsoft AI Research, M12, and Sarva, Advisor, Head of Product Security, NetFoundry. Thanks for listening to this NetEvents podcast. A full transcript plus presentation deck is available from www.netevents.org.